All right, so as I'm sure you already know, in an atom are 3 subatomic particles: protons, neutrons, and electrons. If we look at their mass in kilograms, we can see that they are very, 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 very small. 1.67 times 10 to the negative 27 for protons and neutrons, and then even smaller than that for electrons. You can also see there's a charge in coulombs, which is the SI unit of charge. Proton is positive 1.6 times 10 to the negative 19. Electron is negative 1.6 times 10 to the negative 19. But these numbers are just kind of hard to deal with. And so really what we end up using is the relative mass and the relative charge. The relative mass is in a unit called atomic mass units. And the definition of atomic mass unit is right there. So 1 atomic mass unit is equal to 1/12 the mass of a carbon-12 atom, and that's a carbon atom with 6 protons and 6 neutrons. So proton relative mass, we just say, is 1 atomic mass unit. Neutron relative mass is 1 atomic mass unit. And then electrons' relative mass is 0. And we can say that an electron's relative mass is 0 because it is so much smaller than a proton or a neutron. It's about 2,000 times smaller than a proton or a neutron. So if you added, 1 plus 1 plus 1/2000th of something, you're going to get basically 2. For relative charge, protons, just to simplify it, we're going to say they are +1, neutrons are 0, electrons are -1. Oops. There we go. So elements are defined by their number of protons. This is referred to as the atomic number. So the atomic number is the number of protons in an atom's nucleus. It is the most important number to the identity of an atom. You don't really want to use mass or anything like that to identify an atom because of something called isotopes, which we'll talk about in a little bit. So the number of protons defines the element. Oxygen has 8 protons. It is the only atom that has 8 protons. If there's an atom that has 8 protons, it is oxygen. There's no question about it. And the periodic table is arranged in order of increasing atomic number. The chemical symbol is a 1 or 2 letter abbreviation that represents the element. Sometimes they're fairly simple, like hydrogen's H, helium's He. Sometimes they're a little weird, like sodium's Na. That's just because if they're weird, it's usually the Latin or the Greek that were used, the Latin or the Greek names that were used to create that symbol. So what is the name and symbol of an element that contains 50 protons in its nucleus? That means we're looking for atomic number 50. As I said already, the periodic table is arranged in order of increasing atomic number. So I just scan across the periodic table until I find atomic number 50. So the name is tin, and the symbol is SN. And again, that's one of those weird ones that comes from, I believe, the Latin. Isotopes are when the number of neutrons in an atom varies. All atoms of a given element have the same number of protons, but they do not necessarily have the same number of neutrons. Now, one common misconception about isotopes is that there is no, quote, normal atom and then an isotope. Every atom is considered an isotope. So like carbon-12, 99% of the carbon in the world is carbon-12, but carbon-12 is still an isotope, just like carbon-13 and carbon-14. Some elements have only 1 isotope. Most of them are going to have 2 or more, up to 5, 6 isotopes. Relative amount of each isotope in a naturally occurring sample is fairly consistent. So like I said, carbon is about 99% carbon-12. So any sample of carbon that I get is going to be about 99% carbon-12, and then a very small percent of carbon-13, and an even smaller percent of carbon-14. The mass number of an element is an important number. It is the number of protons plus the number of neutrons. If you remember that the relative mass of a proton is 1 and the relative mass of a neutron is 1. So this is why we add those together to get the mass number. Since isotopes have different numbers of neutrons, they would also have different mass numbers. Stop it. All right. So there are two different ways to write an element symbol. It's called isotope notation, but again, remember that really any atom is an isotope. So the first way, the way that I use most often, is the way on the left here where we have the chemical symbol, and then the mass number is written to the left of the chemical symbol on top. The atomic number is written to the right of the chemical symbol on the bottom. And you can see some examples there with neon, the 3 isotopes of neon. Another way to do it would be to write the chemical symbol or name and then a dash and then the mass number. So that's not like a subtraction. It's not neon minus 20. It's just neon 20, neon 21, neon 22, indicating the neon 20 has a mass of 20, neon 21 has a mass number of 21, and neon 22 has a mass number of 22. So what are the atomic number, mass number, and symbol for the carbon isotope with 7 neutrons? So we would find carbon on the periodic table. Carbon's atomic number 6. So, I guess I should write that out. So the atomic number is 6. The mass number would be protons plus neutrons. So if the atomic number is 6, that means protons are 6. So that would be 6, and then the problem tells me that I have 7 neutrons, so the mass number would be 13. And then symbol, we could write it one of 2 ways. So we could write it carbon 13, 6, like that, the mass number on top and the atomic number on the bottom, or we could write it as carbon 13, or even less common, I rarely ever do this, but just the symbol and then the mass. All 3 of those would be a way to indicate that you have that isotope of carbon. How many protons, electrons, and neutrons are present in an atom of potassium? So again, when it's written like this is the mass number on top, and this is the atomic number on the bottom. So protons is equal to atomic number, so it has 19. Neutrons, so if mass is protons plus neutrons, we know the mass number is 39. We know the protons are 19, so easy little math there. Neutrons would be 20. Electrons, if this is a neutral atom, I don't think I talked about that yet. If this is a neutral atom, protons would have to equal electrons. Positive charge has to cancel out negative charge, and so there would be 19 electrons in that potassium isotope. Right? So carbon has 2 naturally occurring isotopes, carbon 12 and carbon 13. Oh, they even left out carbon 14 because it's so rare. There is a carbon 14 as well. So in this equation, or this picture here, circles represent protons, squares represent neutrons, which image best represents the carbon 13 isotope. So in the carbon 13 isotope, we know that there's going to be 6 protons because carbon's atomic number 6, and there's going to be 7 neutrons because that's how we get to the mass number of 13. And so if I count these up here, I'm looking for 6 red circles and 7 blue squares, and the one that has 1, 2, 3, 4, 5, 6, 7 blue squares, 1, 2, 3, 4, 5, 6 red circles is A. All right, ions. Oh, so there it is. In a neutral atom, protons is going to have to equal electrons because positive charge would have to cancel out negative charge. But during a chemical change, or when a chemical bond forms, an ionic bond forms, atoms can gain or lose electrons and become ions. So the definition that I always use for ions is just atoms with a charge. So if we look at a neutral lithium versus a lithium with a +1 charge, the neutral lithium would have 3 protons, it would have 4 neutrons, and it would have 3 electrons. To get that positive charge, protons doesn't change, neutrons doesn't change. But what happened to get a positive charge is it lost one electron. So it would have 2 electrons. With the fluorines here, so the neutral fluorine is going to have 9 protons, 10 neutrons, and 9 electrons. The fluoride ion is going to have, fluoride ion is going to still have 9 protons. It's still going to have 9 neutrons, but it has a negative charge, which means it gained 1 negative thing or 1 electron, and so it's going to have 10 electrons. So the charge, to get the charge is always like the opposite. So if I have a positive charge, I lost electrons. If I have negative charge, I gained electrons. Cation is a positive ion. And as we just went through, positive ions are formed when atoms lose electrons. An anion is a negative ion, and this is formed when atoms gain electrons. So just to be clear, it's not like electrons are like floating around and then an anion or an atom's like, I want to be an anion, and takes an electron. If an atom's losing an electron, what's actually happening is it's being donated to another atom, and this is how we get ionic bonds, which we will get into later. So how many protons, neutrons, and electrons are in this oxide anion? So I did put the mass number on top there because you really shouldn't use the periodic table to determine mass number. What's on the periodic table is called the atomic mass, which is different. So protons would be the same as atomic number, which for oxygen is 8. Neutrons is basically mass minus protons. I'll write it out. So mass is protons plus neutrons. So my mass is 16. So my neutrons is 8. And then electrons, so in a neutral oxygen, there would be 8. This has a negative 2 charge, which means it gained 2 electrons, so there are 10.